So let's just set the stage for the class. Let's talk a little bit about why we're interested in software acquisition and what it is that we're trying to accomplish in this class, and maybe get a feeling for sort of where we've been. So I'm going to use some words from the DoD documents. These are words that you may have heard. And the first one is deliver resilient software capabilities at the speed of relevance. You know, it's like you've probably heard the speed of relevance a lot. And maybe you haven't thought about speed of relevance. It's like, are we talking DoD acquisition? How is DoD acquisition at the speed of relevance? And if you thought about that, it's like, okay, what exactly are we talking about? And as we start looking at the software modern vision for the DoD, they start talking about to deliver resilient software capability at the speed of relevance. And I like to dwell on these words for a minute because it's really important that we get a setting. So what is resilient software? Does anybody have an idea about what resilient software is? You can raise your hand. I'll call on you. If nobody raises their hand, then I'll just call on somebody. That's sort of how it works. Resilient software. What is resilient software? What is the word resilient? Joe, please.
I would just say it's ability to bounce back and withstand any issues. So if basically your Toyota, as opposed to your German engineering vehicle, where it has to be ran exactly how the manufacturer says, whereas the Toyota, basically they have thought of everything of how it fail, and they're expecting the customers to throw the kitchen sink at it over.
Okay. All right, cool. I do have a Volkswagen ID4 electric vehicle, and I would say that's probably the case. Is anybody in this class resilient? Matthew, are you resilient?
I hope so, or else I'll be in trouble here in my job. No, I think a lot of times, especially from the DoD, resiliency is very tied to security and the ability to withstand, threats and, cyber mitigation steps, but also scalability. So a lot of, buzzwords nowadays is MOSA, modular open system architecture, which is something that's challenging to do if you do it right. So I think of resilient, it's built to, not just withstand, but also adapt to, inputs and outputs that, grows the system with time. That's not, trying to start from phase zero again, which is mostly what we do for software today.
Yeah, no, I'd agree with that. How about, self-healing AI, yeah. How about redundant? Is redundancy a form of resiliency from a system perspective?
Absolutely.
Yeah.
The adage on the destroyer, and any weapon system, like a loss of redundancy is a loss of capability. Over.
Yeah, or increased risk of failure. Redundancy is it's resource intensive, right? You're having multiple versions of the same system running and one in the background in case you lose the primary. And that's not what we're talking about in modern software. What we're talking about in modern software is like, has anybody ever cut themselves with a knife? Not on purpose, I mean by accident. If you did it on purpose, that's another discussion. Anybody ever cut themselves with a knife? Chopping veggies. Yeah, my wife almost cut the end of her finger off. Do you die? Do you bleed out? Does all the blood go out of your body with this cut? Would you not say your body is resilient, right? You break a bone, you lose a limb, you have a cold, you get COVID, right? Your body's resilient. It doesn't just fold. And if you think about the human body system of resiliency, that's sort of what we're talking about in software. We need to design software that ultimately has the ability to be resilient and withstand attack or failure. And the cyber thing is definitely in that job queue. So it's a different type of software architecture. It's something different that we've never done before. If we say resiliency, I'm not saying redundant, even though that is a form of resiliency. When I say modern software, a vision on delivering resilient software capability, I'm talking about software that can heal itself or withstand attack based on its architecture. That's what we're talking about. Okay, at the speed of relevance. What is relevance? Anthony?
It's basically saying you're able to provide a capability when it's needed. A lot of things take a long time, and you can be searching for the perfect solution forever. But if you take too long and you're overcome by events, then it's no longer relevant, not needed.
It's when it's needed. That's a great term. Why don't they just say that? When it's needed.
Doesn't sound as fancy.
Yeah, I know. Relevance. Would you say we in the DoD we have a history of delivering capability when it's relevant?
I know, and it's hard with our governing JSID's process. It's not a time sensitive or flexible construct to buy and build things as they're relevant.
Yeah, I would say for folks that have been around for a while, like me, I was around during the Cold War, and we were matching or trying to stay ahead of the Soviet Union for a long time, right? As long as we stayed ahead of them, we were sort of okay. As long as we had the advantage, we could maybe deter a nuclear war. We were successful so far. And maybe if we meet them in battle, or if they're going to do something in Europe, we would have the advantage. We were able to deliver capability that was relevant at the time because the pacing threat looked a lot like us. Pacing threat looked a lot like us. We went through sort of this global war on terrorism and stuff. There was no technological challenge in that arena. And then something sort of shifted as we started looking at a rising China and a China that wanted to be a world power, a China that wasn't constrained to Cold War thinking and trying to match. They were like taking advantage of the technical commercial enterprise and stealing their way to where they're at today. There's nothing that they've developed that we didn't give them, or they weren't able to steal or to copy from someone else. Okay, that's sort of where we're at. And when you look at if you just envision a country that is able to develop software using modern methodologies, it will hands down beat us with our waterfall methodology and our slow acquisition processes. So that's the urgency here. The urgency is we have to deliver resilient software capability at the speed of relevance to match and stay ahead of this Chinese threat. That is the message that is being sent, and this is something that you need to sort of grasp. And a lot of this is about why are we doing this and why do we need to change? And it's exactly that. Could we continue to do what we're doing? Waterfall methodology, sure. But we're going to have some challenges, especially as we start thinking about cybersecurity and other things. I like this slide a lot. It looks like something you may have seen in the past, right? The Big A acquisition, these 3 intersection rings, but that's not what this is. This is basically the pillars to achieve resilient software capability. They're trying to quantify what does resiliency mean from a software perspective. We can start at quality. Quality of software. As a defined quality of software, it really has to do with the user. Is the user getting the things that they want, all the features that they want, And is there minimum defects in the software that we're delivering? Are we delivering a quality product that meets what the warfighter and the user wants? That's their definition of quality. Can we do that? Today, I will demonstrate to you in a couple weeks. We do not deliver quality software products. I'll tell you right now, the Aegis combat system, the weapon system that are on destroyers and cruisers, has over 6,000 deficiencies, software deficiencies. It is not a quality product. We do our best. There's reasons why they have all these deficiencies and stuff. I'm not belittling them at all. I've had a tremendous amount of software deficiencies in my programs that I ran, but that is just sort of the fact. Our processes really didn't allow us to correct deficiencies, find them early enough to correct them, and also the architecture was intertwangled and twangled. Is that a word? Intertwined. Stability. The software works. It doesn't crash. It performs like it's supposed to. It's able to scale when it needs to scale to match demand. If you have 20 tracks on your radar, is the combat systems able to recognize the 20 tracks and do what they need to do? What if you get 1,000 tracks, like a bunch of little small UAVs you're trying to track? Does the Aegis combat system scale today before it crashes because it can't handle 1,001 physical contacts? Stability of software is a big deal. I have operational experience with software that was not stable. We'll talk about that in the class. Just to give you an idea, if you have not experienced stable software, the new car that I got, the ID4 Volkswagen electric car, has a software stability problem that every now and then the software would crash as I'm driving it. Not a awesome experience when you drive an electric car that's run by software. There was redundancy in the system that allowed it to continue while it rebooted the software in the car as I'm driving down Interstate 5. Not a pretty picture. They fixed that. It hasn't happened in a while, but still, software stability is really, really important. And as we start thinking about security, software that detects a cyber event or somebody inside the system resists a cyber attack. A cyber attack is always going to happen. There's nothing that you can do. It's going to happen. Are you able to resist the attack? Are you able to be resilient during the attack? Offering the warfighter a quantified degree of cyber survivability. Can you survive an attack? We're no longer saying, well, we're going to prevent it using a gate guard, using cryptology. We're going to have disconnected systems and trusted. No, that is done. I'm going to say something to you, and this is not something that is from me. This is coming from the higher ups in DoD. All of our systems have been penetrated by the adversary. They're already in our systems. It's a very interesting and concerning fact. I think it's more of a statement. Let's just say they're in there. How do we build software that is able to operate while someone is inside your system? How can we build new software that basically is able to detect anomalies? And we'll talk about the solar winds and some of the things that happened during that event in week 4. And that's an important thing. But when you look at all this together, we start getting a vision of what resilient software is. It's quality software that doesn't have a lot of defects. It's software that is stable and is able to do what the operator needs when they need it. It's available. And it's secure. It's able to respond to some sort of cyber event to resist and continue to operate while there. And so this is really when we think about resilient software capabilities, this is the connection of things as it comes together. So I think this is an important thing to sort of get under our belts. I like it. Nice chart. Software is everywhere. I mean, it's around us. You guys have it. It's in everything you touch almost today. This Zoom software that we're using is an example of us being able to communicate and do things that you couldn't have done 15 years ago very easy, or 20 years ago. It's in our vehicles. Unless you're driving a 1965 Ford Mustang, your car has software in it. Anybody give me an example of a piece of software in your car? Some feature of a software in your car.
If you have any sort of a digital display, there's going to be software tied into that.
Yeah, okay, yeah, your display, yeah. All right, what else is in our vehicles that is software related?
Yeah, I can't live without my adaptive cruise control now.
Yeah, you know, first time I had that happen, I was on Interstate 64 coming out of DC, and I rented this car and I put it on cruise control. Actually, I got on 81 going south, and I'm going up this hill and the car's slowing down. I said, what a piece of shit car. I said, it can't even hold its speed. And then I was like, wait a minute, there's a car in front of me and it's pacing this car now. I said, I don't want to do that. I want to go around it. So yeah, adaptive cruise control paces the car ahead of you. What else? Yeah. Go ahead, David.
Yeah, I mean, I've got an electric vehicle that has like the entire thing is all software, and the collision detection to the step above cruise control where it's like lane finding and everything like that. So it's
Yeah, I like to do that with my wife hates cruise control. Always from the beginning, she could never take cruise control, and the ID4 has lane centering, so it will drive itself like that. So occasionally I'll be like driving and you know, I'll get a curve and I'll turn around and start talking to her, and she's like, put your hands back on the wheel, you know.
Yeah,
it's with her.
my young kids love it, you know, watching me take my hands off the wheel and it turn itself.
Yeah. Oh, well, you talked about braking too. The car that I have will do an emergency brake if it determines that you're going to hit something. And unfortunately, I tried this feature with my wife in the car, and I did not understand at what an abrupt stop was. When it decides it needs to stop, it ain't like let me press down on that pedal. It's like, I mean, and if I didn't have my seatbelt on and she didn't have her seatbelt on, we would have went through the windshield. It was that abrupt. It was pretty amazing. She's like, what happened? I was like, I was just seeing if it worked. And she said, never do that again. Yeah, it's everywhere. It's in all of our weapon systems. It's in definitely in all of our IT systems. So why would we treat software and develop software and manage software like hardware? And that's what I'm going to try to sort of point out to you, that we've done this up until 2020. I'll give you that we treated software, embedded software in a weapon system as a system. Just treat it the same. We'll develop it the same. It's all around us. And most of our military capabilities are enabled by software. The F-35 would not fly if the software computer systems, flight control software failed. It would drop like a rock. There are no cables, no hydraulics basically connecting the joystick to the pilot and to the wing controls and the engine controls. It's all software control. It's amazing as you look at the amount of software that our weapon systems have to where we're at today, and you sort of wonder why we're having a problem keeping up, because we develop software using a very archaic process. As AI, artificial intelligence, is now becoming a reality, as you've seen last year with ChatGPT and all this other stuff, AI being able to provide information that maybe the user would not recognize, helping the user make better and faster decisions, to be able to sort through a tremendous amount of data and make sense of the data with maybe conceptual things. This is on its way. This will change, in my opinion, the art of war. Having AI, artificial intelligence, basically looking at data, making recommendations that are valid recommendations. This is happening, and AI is software, no doubt. This is advanced software techniques. Machine learning we've had for some time, and that again is software enabled. The DoD, from policy perspective, we will not let AI make a kill decision. The human has to be in the loop to press the button to say, kill. Now, I don't know if China and Russia have that particular policy. They are not far behind us, if not ahead of us with AI. They have invested large amounts of resources and intellectual property into AI. Who knows the next time that we are in conflict with China, if we go into conflict, we may be facing an adversary who's able to make a faster decision because they're relying on AI. May not be the best decision, but that's sort of our policy. Software. So what's the big deal? Why now do we have all this cyber challenges? We will talk about this in week 3 in detail, but the attack surface has increased. Our ability to connect our systems together, to connect them to the cloud, to connect them to other sensors, allow our systems to be more vulnerable and have a larger attack surface. And that's induces more risk of having a cyber event. So we need to design our software to be resilient. There we go. I got that coming around. They know this. Their systems are just like our systems. They're software driven. Believe me, we're investing time in trying to exploit their systems, right? That's counter cyber, that type of stuff. But they are investing large amounts of resources. We call it the advanced persistent threat, APT. Advanced persistent threat is state sponsored. This ain't, some guy who's 36 years old living in the basement of his mom's house, right? These are thousands of people in a building in China dealing with cyber exploit. Okay, they are invested in this. They are doing this in spades. This is their national interest, and we are doing our best, but we definitely don't have the focus that they have on trying to do exploit and attack our systems. Threaten our infrastructure. This is what freaks me out. China decides to take Taiwan. They've been threatening it. They've been doing it. They turn the lights off in San Diego and Los Angeles. The lights go off. The water stops flowing out of your tap. Your ATM machine doesn't distribute money anymore. When you go to get your groceries and use your credit card, it doesn't work. So you have no money, you have no credit, you have no electricity, you have no water. How long does that last from an infrastructure perspective until China basically says, when you had enough, we'll turn your lights back on? That ain't so far-fetched. We have spent probably the last 10 years from a president executive order to help our commercial industry, our commercial infrastructure harden, that we resist these type of things. I mean, look at was it last year or 2 years ago, the ransomware attack on the pipeline on the East Coast? Turn the gas off for a day. People freak out. It's like, oh my God, how am I going to get my car going down? Yeah, ransomware attack. So big deal. We'll talk more about cyber, a little bit about cyber. Fighting and winning on the next battlefield will depend on DoD's proficiency to rapidly and securely deliver resilient software capabilities. More of the same. more of the same words, right? These are words from the DoD software acquisition documents. Pretty big deal. We get software in various ways. Within DoD, we can get software from other DoD organizations or government organizations. So we can get those applications. We can do that. We can buy the software through licensing, right? We buy Microsoft Office 365 for everybody. You know, we got the wonderful system of being able to get licenses and have commercial industry provide these things. Software as a subscription, this is Amazon Web Service, that type of stuff. And then there's software that we develop ourselves, that we build for our complex weapon systems and other things, and embedded code and weapon systems. So these are some of the software areas that we're going to touch on. I'm going to spend more of my time talking about the custom software because that's sort of where we have some control. But we got to sort of think about where is security being built in through these commercial components that we're actually bringing into our system, especially tools that we're going to be using in the future for software development. These are all commercial components. And then hopefully if we are using other software that's been developed by another DoD component, like the Air Force or the Army, then maybe they've had security built into that too. So hopefully we got that. However, we obtain software, the delivery is not a one and done activity. We got to basically sustain this software. We have to update it and make it modern and to address modern capabilities that basically could be harmful to the system. So we're going to say something in this class that software is never done. Our acquisition process really is, when we think about it, is, you know, we have this deliberate activity, we have these milestones, we get to a certain point, we hand it over to the user, we said, and we're going to support that. Good luck. We're moving on to the next thing. Traditionally, that's sort of how we've viewed it. Now we're saying software is never done. How do you continue to modernize and add new features and capabilities to it? This is a big shift we'll talk about in this class. Josh?
Hey, sir. So you made the comment that software is never done. I think in one of the homework questions you assigned, it said, when is software complete? Is there a difference between the two?
Yeah, software is never done. It's never complete. In the modern architecture, the way that we're going to be thinking about it. Yeah, software is never completed. Using a new architectural view, a new modernized way of viewing software. We're going to discuss that. You'll see it. And actually, in reality, it's never done, even in today's environment, right? As soon as we finish the software, or at least from our perspective, we finish the capabilities and we have operational tests and we get all the certifications, we usually hand it over to a software support agent, an SSA. The software support agent is going to deal with making sure that the cyber vulnerabilities are addressed, any deficiencies are corrected if they're high enough priority. We've always sort of supported the software throughout its life cycle to where it ultimately is disposed of and replaced with something else. So we've always had the conceptual cradle to grave. So software is never done in a new context, basically is saying we can continue to add value to this software as the user is discovering new ways of using it or new threats going on it. So hopefully by the end of the quarter, you'll have a better appreciation for it. But from a question perspective, when is software complete? When we dispose of it, and it's no longer in service. Yeah, and DoD 5000.87 in the chat here. That's the homework question. And when you look at that, I have a slide that shows that if you're using the adaptive acquisition framework for software, and you're going to use that pathway, there is that conceptual view that software is never done. You're going to continue to add capability to this software as long as the user demands it. Okay. We'll take a break here in a minute. I just heard colors go here in Monterey.
Hey, sir, do you think the movie that recently came out, Leave the World Behind, do you think it's one example of this vulnerability that we face daily with software?
Well,
Over.
what movie? I didn't hear it.
The World Left Behind.
Oh, for God's sake.
People just sitting there, we're going crazy. You know, I know it's all sci-fi and whatnot, but at the same
Yeah,
time,
you know, the wife and I watched that, and really, The World Left Behind. Some great actors in it. I had some high hopes for it. The one scene was all the Tesla cars, basically all the new cars coming off the parking lot and jamming the highway. So it was a cyber attack from a national level. So probably an advanced persistent threat, someone basically doing something. So it's interesting. Yeah, it's sci-fi, but sometimes these aren't far off. You know, somebody thinking of, you know, taking down the internet, taking down a lot of capabilities that we rely on, to where, you know, yeah, why not? We can. It's good to think about the worst things that can happen, and then build our systems and reinforce our infrastructure to where it's able to respond to it. We start talking about modular design and automation. Modular design, it was mentioned about the MOSA architecture, the modular open system architecture. That is a system engineering way of thinking about, you know, being able to replace things without replacing everything else around it, that it becomes modular, as sort of plug and play. You know, we think about software in that fashion too. And we think about being able to replace or add new components to software, not have to recompile the entire software code. We start thinking about automation as far as testing goes, to do automated test and retest, to be able to test the software to make sure in an automated way, not having a person basically, you know, test and push the button, have the system do the test and come back with results. So we'll talk about that in this class also. How do we actually achieve that? So the transformation, the how do we transform our DoD software modernization framework? How do we recognize that we have to change and take advantage of our commercial industry that's been doing this for about 15 years now, or maybe a little bit longer than this? Their tools and their methodologies at Apple, at Microsoft, at you name whatever commercial company is out there, they develop software a lot differently than we do. They develop software that is secure as it can be and as relevant as it possibly can be in order to capture the customer, right? That's how they make money. So let's look at what they're doing. Maybe that's a way to look at a process change. A lot of this has to do with culture in the DoD. As we start thinking about, you know, leadership telling us we need to change the way we develop and acquire and manage software, we have to set up the situation to be receptive to that. We got to set up the processes within the DoD. How do I actually accomplish this? We mentioned about like the requirements process and the JSIDs being very slow. If there's something slow, let's decide whether that's a value and maybe we do it differently. We know we have a budgeting problem with our PPBE, our planning, our programming, planning, budgeting, execution system, the way we get our money. We know we have a problem with that. It's not responsive to near-term threats or near-term needs. And we're having to make a decision whether we're going to continue to follow that for software. They're working on that as we speak. And we got to understand what it means to deliver software at the speed of relevance. Doesn't mean we get 2 years to do testing on it and certification on it. That is not speed of relevance. That is legacy waste. So we got to look at all of this behavior and all of this cultural stuff and make sure that we're all aligned. Get one of these things out of alignment and it slows and destroys the entire process. How do we do ATOs, authority to operate? How do we get a piece of software that is actually being able to be used on the network? A very horrible, deliberate process and questions the values of added of a process like that, when maybe I can shift that left and actually do it during the development of the software to make sure that it's cyber secure, that it meets all of the standards. Do it left. Don't do it to the right after it's been done and sitting on somebody's job list to do stuff. We got to start small. We've started small. We got pilot programs right now that are doing modern software acquisition. There's, I think, about 24 DoD acquisition programs today. I know it's a small number that are actually doing and have the authorities to do modern software development from a funding perspective and also from a procedural perspective. There are over 3,000 DoD active acquisition programs in place today. There's 24 that are running this pilot thing. But you got to start small. You got to start somewhere and eventually get to the enterprise level of this is how we're going to do it. So we're at a definitely at a transition time within DoD in the way we're doing software development. And the things that we need to get out of this, you got to say, well, why are we going through all this pain? And you got to start looking at your desired outcomes. So we want to shorten acquisition timelines. That is the whole adaptive acquisition framework that you studied previously, that you're aware of. And from a software perspective, we got to do there. We got to break down our business operations and make sure that we have incentives to make these things work all together to give us what we need to the warfighter. And we need to reduce the lead time for cybersecurity compliance. RMF, the risk management framework, is our cyber process in which we decide whether things are compliant. We need to basically reduce that time and basically build it into the software development. That's DevSecOps. That's the sec part. So we got to shift that to the left. And when we're ready to deliver a software capability, we're able to push it out within 24 hours or 48 hours. First time I heard that, I said, you guys are full of shit. There's no way you can deliver software to a user and get it into their hands from the time they need it to the time they use it in 48 hours. I said, our processes they don't conform to that. There's no way. We've had some demonstrations at NIWC PAC about 15 years ago. They were actually able to do it. The SecNav basically asked them to do it and demonstrate that they could actually deliver software that quick. The last one that's publicly known, that's pretty popular, is the Kessel Run Air Force has a software factory up in Massachusetts. And during the Afghanistan people withdrawal, Air Mobility Command asked for a feature that they did not have. And Kessel Run basically was able to deliver that capability within 48 hours to be used in the evacuation, whatever particular feature it was. So we got to get there. We need to understand the roadblocks, and we'll talk a lot about that in the class. This is break time, and we'll move into the DoD Department of Defense software modernization strategy. This is where I got a lot of these points from. So this document is really a document that I reference a lot. This is a November 2021 document from the DoD, and it does give us a little bit of guidance of what it is we're supposed to be accomplishing in there. There's some underlying principles that sort of set this up. March 2021, basically saying there's a revolution in technology that's happening, and it is provides both promise to the DoD if we can embrace it. And are you running on a treadmill? Oh, for God's sakes! Imperial, you're gonna get me sick. Turn your video off. You're starting to bounce me on me. And so basically, when we start thinking about a technology race and everything that's emerging, this is a big deal, and this is really what is driving us. The DoD runs on software, no surprise to that. All of our weapon systems, from autonomous, unmanned, unattended space systems to advanced fighter jets, this is all software. So we got to understand that and understand what it is that we need to do. And the real question is it too late? Have we waited too long? Have we diddled too long? Has the threat basically come upon us so fast that we're not going to be able to make a change? I don't know. Maybe it's not too late. Maybe the generation that is serving in the military today is more adaptable and able to respond to a change of environments like this. Some of the tenets of that document basically says we need to be able to evolve faster and to be more adaptable than our adversaries, right? This is all DoD military talk. It gives us, we need a competitive edge that will define future conflicts. We need to be on the right edge, right end of this transformation. We got to deliver software, not the way that we've done in the past, taking years to develop, to actually delivering software in minutes. I mean, if you're like, what, 24 hours, 48 hours seems like a big stretch, but delivering software when you need it, have authorization to send it out and send this capability to the tactical edge in minutes. And we'll talk about the vision of how we possibly can do that. And if you say, well, the DoD, there's no way we could possibly do that today in our current establishment and our processes, you're absolutely right. And this is the change that has to happen within our enterprise. Big deal. So we got to shift software delivery left. And the way we do that is by using modern infrastructure that has been developed by the commercial enterprise, and the platforms and stuff that basically are out there, cloud services, all this other stuff that we got to do. This is what we're going to cover in the class. What is it when I say we need to have a modern infrastructure and we need to shift cybersecurity left? That's what we're going to be talking about. So that's sort of we're still talking about what it is we're going to be talking about in the class. We gotta change our processes, and we need to develop our people to where they're able to understand what it is we're talking about. How does leadership convey the need that's going to have to be, and the changes that are going to have to happen in our culture? If anything that we need to think about is our culture has and especially in the Defense Department, we have a culture of resistance. We've done it this way forever. There's nothing wrong with the way we've done it, or we have some spectacular weapon systems. I'm not saying we don't, but if you need to be able to match an adversary and respond, you cannot develop software and capabilities like we've been developing in the past. That's just simply it. Software will be a differentiator in the continued defense of our nation. If we don't get a handle on this, and start using the building blocks of this emerging technology, we're going to have some challenges. We got to, it's a critical asset we must defend and exploit to take it to our advantage. And we got to take steps in the DoD to modernize the way that we develop software. And so this document from 2021 is the first step. I'll show you there's additional documents that have been written and published. And ultimately, our vision is to deliver resilient software capabilities at the speed of relevance. So that's sort of where we are. Are we ready for change? Okay, so that sort of gave us the introductory. I want to talk a little bit about waterfall. You may have seen on the quiz, waterfall is not necessarily bad if there are conditions that basically set it up and allow us to do a waterfall development. But I'm going to sort of tell you as we start talking about waterfall methodology, and this is the only time I will talk about waterfall. The Undersecretary for Acquisition and Sustainment, the previous one, Miss Lord, when she was setting this up, she basically said, "Thou shalt not do waterfall development for software." She basically said there's no condition that the DoD is in that we should be doing waterfall methodology. So I'm going to talk about it. I'm going to show you what it is. You're going to recognize it because this is really what the DoD is good at doing, waterfall methodology, and we need to make a shift from waterfall to something else. So if we have all of the requirements, sort of a handle on all the requirements and what it is we're going to build, and it's a non-changing, non-dynamic environment, then waterfall probably is okay. And everything else, you should be doing something different than waterfall. So it's a traditional approach. Write down all the full specifications, all the requirements, and we're basically going to use these documents to write the software and also to test. When we pass all the tests, then we consider it finished and ready for the user, right? And it's a given way of developing our systems. We start with the requirements, JSITS process. We start with our design. This is milestone A. This is maturation, technology, risk reduction, all this other stuff. We start implementation. We get a contractor on board and we have them start building it for us. And then we do some testing and verify that they built it right during operational test. We give it to the user and we maintain it. That is our DoD acquisition process of the past, and that's sort of the culture that we are in today. So we need to have a cultural change if we need to get out of that. Here it is from a time scale. This is the reason why it takes you so long. From the time that you do contract award at milestone B to where you get to milestone C is 5 to 7 years. You get nothing. You get nothing during this development cycle. The problem with waterfall is sometimes you may not know all of the requirements. The design of the system may be flawed. You may not know that till you get into actually doing it. So it's very common for waterfall teams to think they got it all right, only to discover serious flaws in the architecture or something else, and they have to go rework. And that's sort of the reason it takes some time to do that. That's what we've been doing. So we're going to do something different. So, it can work. There is that caveat. We've made it work over the last, since the 1940s, as we start the modern, going into the modern architectural. So we've been doing it for 70, 80 years. So it can work if you know everything in advance and you got plenty of time to do it. Our culture, the DoD culture, and I'm telling you this, is it lends itself to a waterfall process. It is what it is. We've done it this way. Our budgeting system is aligned to a waterfall process. Our requirements process is aligned to this. Our acquisition process for many years have been aligned to this. Now we're saying we got to change. Resistance is it's definitely there. So it's good and bad. You got everything you need. That's all I'm going to talk about waterfall. So this class is not about the past. We're going to focus on the future. So we're going to talk about Agile. Agile, you probably have heard of it. You probably maybe have been exposed to it, a little bit of it, but let's talk about the fundamental practices of Agile. So Agile is based on a lean process. Anybody heard of Lean Six Sigma? Yeah. it had its genesis and implementation early with Toyota. Back in the 70s, Toyota was delivering an inferior product. They wanted to be a rising car manufacturer. They were having lots of problems. They brought in this industrialist who basically employed a lean manufacturing process. And agile basically looks a lot like lean. We're trying to reduce inefficiencies. We're trying to increase communication. And so this process that we're going to talk about is pretty straightforward, and it should be to make sense. And it does work, given the right conditions, given the right cultural responsiveness to it, given the right amount of tools and processes and funding, it can work. So if I just show up today and I said, all right, we're going to do lean software development, I got to do the training. I got to make sure that all of the processes are in place that allow us to do this type of work, and make sure that we reduce all the barriers that prevent us from doing it. So we're going to talk about it. So if it's great, how come everybody isn't doing it? In the real world, there's a lot of challenges, and if you don't reduce the barriers and if you don't change the culture, you're not going to have success. So what is it? It's a set of methods and methodologies. It is. It really is a different way of doing things. And like I mentioned, it's based on lean principles. So let's talk about it. I'm going to talk about Scrum. There's other agile methodologies, but Scrum is the most common software methodology. So I'll show you the pattern of agile and sort of how it works. This is not a class on agile development. I'm going to talk a little bit about it. We're going to focus a lot on DevSecOps, which employs agile as a software development activity. So let's at least understand what agile is and how it operates. So we're going to spend a half hour or so talking about this. This is a Scrum pattern. All right. Anybody know where the word Scrum comes from?
Shot in the dark, but rugby.
Yeah, right. It's a group of people that basically get together, and there's a Scrum. They basically get and they do all this stuff, and so the Scrum is a group of people basically working together to develop and achieve a certain goal, right? And so they use the word Scrum as a process, getting together and pushing in the same direction. So in this particular pattern, this is a Scrum that basically is working on getting features that the user needs into their hands based on certain cycle. So they're doing a 30-day Scrum pattern. So every 30 days, they do planning on the features they want to develop. They meet daily, and they do a daily Scrum. They do a daily stand-up meeting. It's usually about 15 minutes. You want to keep it light. And when I say stand up, they're standing up. I'll show you what it looks like. And they basically are developing software as they are working through this in teams. And they're basically, there's 21 features that are in the backlog. This is sort of how it is. We're bringing, this is not at the beginning of it, but here it says there's 21. And ultimately, they completed 4 of these features. So of the features that were there, they completed 4 of them, and they're working through them. They're developing the software, and they are delivering at the end of this Scrum, at the end of this sprint. We call these sprints. At the end of this sprint, they are ultimately delivering 4 features that actually work. They are delivering working software that can be seen by the product owner, by the user. They can get feedback on it at this point. Anything that they were unable to accomplish or they had problems, they do a retrospective. And a retrospective basically is a learning event, right? What went right, what went wrong. It's not a blaming event. It basically says, what did we learn about the things that we did? And then they basically will go into the next sprint cycle. Okay. So product owner works with the team to maintain the product backlog, what it is we're going to do. The Scrum Master is an experienced person who is helping the team get past roadblocks and actually is the orchestrator of what's going on. Team members, everyone else on the team. And in this particular event, this is a 30-day sprint. You can do 45-day, you can do 60, is whatever your organization wants to do. I think 30 days is pretty aggressive for the DoD. Sun just came out in Monterey. I gotta give me some backlight. The only thing of caution is when your sprint cycle exceeds 6 months or a year. We call that agile BS. Okay. If you're just doing waterfall within a sprint cycle, then that's agile BS. So when people see this initially, especially uninformed people, they'll look at this and they're like, it just doesn't seem like you do a lot of planning. If you look at waterfall, we plan the hell out of this. We spend years planning on what we're going to do, the design and everything. And you guys are just doing this planning out. It seems like it's ad hoc. What they're not seeing is on the left side of this that you don't see on this chart is the product planning itself. How are we going to, what it is we're going to develop, the product that we're actually going to be delivering, and the planning that is over here on the left. So there is some initial planning that's done, not the detailed planning of waterfall, but there's initial planning of how we're going to orchestrate this and set it up. But when we get to the sprint itself, we do planning then. And that's more relevant, right? It's right there. I'm going to try to get 4 of these features done, and let's do the planning, and let's do it right now, right in front of our face. If anything changes, then we can adapt to that. I haven't wasted a lot of time doing too much planning up front. I'm doing it as I go. So when you add up all the planning, in effect, you're probably doing more valuable planning in agile than you would ever do in waterfall, or at least relevant planning. So one of the things that I would say is we actually do more planning than traditional teams following the waterfall process. It doesn't feel like it, but it ultimately is what we're doing. So I've heard leadership say, this seems loosey goosey and requirements are changing and you're not really for sure what you're doing. That's not true, so that'll be my assertion, and I want you to believe it, that this is sort of how it goes. Now, what happens if a user comes in and he says, hey, I know we agreed to these 21 features or whatever that we're doing, but there's something else that I need. If you do that in waterfall, it breaks the process, right? They're like, we accept no more new stuff. We're doing this, and that's what it is. You wait 6 more years, and then you get what you need. In agile, it's a feature of agile that you're able to change what it is you're working on. I mean, I wouldn't do it during this sprint, but if they say, hey, there's a feature that we need, I'll work it in here. I'll get it into the planning process, and that's fine. We'll prioritize which is more important and when. One thing I will caution you from a team perspective, don't do too much hard stuff during the first couple sprints, right? The user may say, I need these things tomorrow. It's like, yeah, but those are really hard. Let me spread this out. I'll commit to giving them to you within the year, but I gotta sort of make sure that my team is able to be successful as we work through this and have a mix of easy and hard stuff as we go through. Does that make sense? You don't want to say, I'm going to run a marathon and I'm just going to go out there and run it, right? I got to sort of work my way up into it. And ultimately the end goal is I'll be able to run the marathon, but anyway, we'll have discussions on marathons. My wife's a marathon runner. So it's an iterative way of continuously working on software and basically building out capability as we go through. It's usually time box, right? We say 30 days, 45 days, 60 days, however you want to set it up in there to set it up for you. And so the backlog list, I showed you that these are the features that the user wants that we're going to deliver, but we're going to deliver them over time. We're going to give them working software that they're able to use, and they can continue to add features. You guys all know this, right? You have a smartphone, right? You know that you continuously add capability as it goes on. First Apple iPhone I had, it was pretty basic. If I look at the 15 iPhone that I have today, it's evolved. They've added new features as it goes through. If you're using Android, God bless you. Not a basher. So with Agile, we want an early delivery of software. We want to get working software into the hands of the user, and we want to continuously deliver software to them, continuously deliver capabilities to them. And ultimately, it's about the user. It's about the warfighter, getting them working software in their hands that addresses a challenge that they're having, and continually adding value gives the user satisfaction. It's meeting their needs. So, we started talking about the speed of relevance. Agile is a way to add capability at the speed of relevance. Now, you may be thinking, oh my God, I know there's all these processes that are in a way, and culturally we have a challenge of getting everything in alignment. So that's the challenge that we're working on in the DoD. We still have roadblocks in front of us. I'm not saying this is a done deal, but we're working on it. A daily stand-up is a process that is used in Agile, and every day they meet and they basically talk about what's going on and challenges that they're having. They keep this short. It's a stand-up meeting, 15 minutes, they're in, they're out, they go back and do work. There's other things that they will do. They'll do like paired teaming. They'll have like two software developers working together at a desk and help, and they find that helps. So there's a lot of advanced things that you can do to make sure the software team is moving forward as they go through this. And so that's what a stand-up looks like. How many meetings have you been in? It's like, okay, we're going to meet for a half hour, and then you look at your watch and it's an hour and a half and the meeting's still not over. What value did that actually provide? What work were you able to accomplish? Most people are on their phones doing something else. But in software development, this is sort of their mantra of basically building software. A lot of teams have a lot of success with Agile, and other ones have really struggled. And it's really when they do an analysis of teams that have failed doing Agile software development, it's usually the culture and the mindset of the people. So we got to sort of change that. And so that's sort of how that sets up. In the DoD, I've seen when I retired from the military, I went and worked as a defense contractor in the DoD, and one of my jobs was to look for new opportunities and new work. And I was looking at a request for a proposal, a draft request for a proposal from the government. You guys know what that is. And in the draft request for a proposal, they were like, we want someone who understands Agile to develop the software. We want Agile software development. It was saying this in the evaluation criteria. It was saying Agile words. It was saying that. And I was like, awesome. Look at this. This is an opportunity. They want a company that knows how to do Agile. Our company knows how to do Agile. And I'm reading on into the RFP, and here in the statement of work, statement of objectives, it's basically saying, and we need you to support critical design review, and we need you to support milestones C. I was like, that's not Agile. I said, the government basically, on one hand, they said, do we want Agile? And then on the other hand, their processes said, and deliver it like a waterfall methodology. My recommendations was do not pursue. they're like, but this is worth a lot of money. They want to do agile. I said, they want to do agile, but they are stuck on stupid. I said, this is a bad deal. So we got to get and the DoD, we have to make sure if we want to change our processes and hire contractors that know what they're doing, we got to get out of their way in some of the things that we're doing. So anyway, so this is sort of the mindset that we got to sort of get into to change our processes, and it is challenging. And how do we make this change? How do we get making sure that the government is set up to do agile from a process perspective? And how do we make sure we get a contractor on board that is able to do agile, and let's not get in their way? That's some of our challenges as we go through this. So the Agile Manifesto, it's worth looking at because this is the principles of the things that they want to do. I like looking at this, and I like looking at it from a DoD perspective, because there's like, we are never going to be able to do this. But this is the change that's in front of us. If we want to do agile, we need to look at the principle values and principles of agile and see if we can actually take this. If you break the Agile Manifesto up, and we'll look at this if you if you don't remember looking at this. The first three values basically talk about early and continuous delivery of software. Early delivery into the hands of the user so they can evaluate what's going on. And then once they get the software, some minimum viable capability release, that they continuously get updates and new capability as it goes. If you can't support that, then you should not be doing agile. You should do waterfall. If you cannot support early and continuous delivery of software to the user, to the warfighter, you should not be doing agile, period. So we got to, if we say in the DoD, we want to deliver software at the speed of relevance, it ain't waterfall. So these are the things you got to sort of get out there. You got to welcome changing requirements. I'm telling you today, in waterfall methodology, if I want to change a requirement, it is like God's thunderbolt had come out of the sky and struck me down. We got to welcome changing requirements from the user as they start seeing the software, they start thinking about ideas and new things they want. That is things that we got to be prepared for. And we got to be able to accept that we're going to deliver working software on a short time scale. We're going to have to deliver this and get through our process in short order to where it's relevant. The fourth value basically talks about how do we work better together? How does the team work better together? How does the contractor work with the government? How does the user, the warfighter, work with the acquisition government people? These are things that we have to think about. There's words they use. They use this phrase over, and it's vital to understand what over means. The manifesto basically says they value this one thing on the left over this other thing on the right. And what they're trying to say, the right is important, but we value the left more. Here's the manifesto words. They value individuals and interactions over processes and tools. You guys have been around for a while. You understand processes and tools is our thing in the DoD. And here they're saying they value interactions and individuals over processes and tools. What does that mean? The contractor actually having discussions with the government acquisition people about stuff, having these meetings with us and talking to the customer about things. This interaction, them talking, is an important part of this. Now, processes and tools are important, but they value this over the other one. Declaration number 2, they value working software over comprehensive documentation. Comprehensive documentation. Comprehensive documentation is what we're all about in the DoD. We will document the hell out of it. And now they're like, no, we prefer to see working software than comprehensive documentation. Another challenge that we have in the DoD is what amount of documentation is enough in order to get us started. Number 3, collaboration, customer collaboration over contract negotiation. We have a contracting problem in DoD. What is the most common contract that we have in place to develop software in the DoD today? Anybody know the contract type?
Can you start the first part of that again? Can you ask that again? Sorry.
Yeah, no worries. I know. That's the problem when, I'm talking in a soliloquy and then I ask a question. What is the most common contract that we use today to develop software?
ASAP,
What?
ASAP, simple acquisition.
Say it again. I'm not catching the front part.
A simple acquisition process, ASAP, rather than by negotiation.
There's 3,000 programs out there today, and that is a initiative to do something like that. But what's the most common software contract that we do today? ASAP is not. It's good, but that's not what I'm asking. Kyle says fixed price.
Yeah, I was going to say cost plus fixed fee, or I've seen a lot of firm fixed price contracts that probably shouldn't have been, but that's just how they fell out.
Firm fixed price is it's requirement based, right? You got to know all the requirements. The contractor says this is the cost is going to be. I'm going to go away and I'll come back and I'll deliver you the software. That's waterfall, isn't it? You got to know all your requirements. You
Yes.
can't change nothing. Okay, so that's probably not the one we need to be using, but yeah. So cost plus incentive award fee type of contract. Cost plus gives us some flexibility, but their incentive fee is based on a body of pre-negotiated work, right? It's based on task requirements, things that they are going to build to. It basically, if it's an award fee pool, it basically says this is how we get profit by doing all this work on all these things that we agreed to do. If you need to change, if the customer is all the time in there, basically giving you stuff, take it out, put it in, cost plus incentive award fee is a nightmare. And so we need to change our contracting strategy. So level of effort is one way to do it, is a service type of contract. We're just going to get you on a service contract. We just want people to do work when we need you to do. So we'll talk about different contracting philosophies later in the course, but I can't be in negotiation with the contractor every time there needs to be a change. Now they're willing to do it. They just want something to be profit bearing. And we don't want to be in that situation. We just say, hey, I want 27 developers, scrum masters, and project managers to be on task, and you do whatever we need whenever you do it, and we'll give you some sort of fixed profit based on that. So we got to deal with this whole contracting thing, and whatever he said about simplified acquisition, these are things that we're looking at to get it set up. Responding to change over following a plan. We are plan-based in the DoD like there's no other. We plan this 5 years in advance. We know everything that's going to happen. We are very deliberate in this. We over and over and over. And now they said, nope, you got to be able to respond to change over following a plan. So you can start feeling that we're going to have some challenges here just by what agile values over what we actually do. So there is a cultural change and there's a process change, and everything else that's out there has to change. So Josh asked the question. So cost plus is the most popular type of current contracting strategy for software development. Yeah. Actually, all of our development activities post milestone B is cost plus primarily. I'm not saying that's good. In the future for software intensive programs, we're going to have to do something other than cost plus, and it may be, but we'll get there when we talk about the challenges ahead of us as we're trying to figure this out, and especially from a funding perspective. Now, there's a bunch of principles that go behind this. There's a lot of reading here you can do and think about what it is they're trying to achieve. This all has to be written into the RFP, the request for proposal. We need to get, if we want to do agile, and we're set to do agile, we need to make sure that we're able to follow the manifesto principles by our deeds and actions within the DoD. And we need to understand the principles behind the Agile Manifesto to make sure that we get out of their way to let them start doing the software development like they need to do. I'm not going to read all these. They're there for your entertainment value. As a program manager of several software intensive systems that were developed, I always got this feeling that I'm 2.5 years into the contract and I haven't seen any software, any working software. I'm like, this seems really weird. And that's how waterfall sort of goes, right? They are coding this, they're working on it. And I'm like, how's it going? How's it going? They're like, well, here's your earned value management. Do not do earned value management on agile systems or on modern software development. Do not do earned value management. Earned value management requires you to do all the detailed design and know all the requirements in advance in order to set your baseline. You cannot do earned value management if you're going to do agile or DevSecOps. Unfortunately, we haven't got out of our way on our processes yet, at least as far as I can find. Earned value management is still required on all government programs that exceed a certain value threshold. So we're going to have to get around this until they give us a waiver. But earned value management is a no bueno. Some people say, well, you can do agile earned value management. Well, why go through the effort? You're going to know right away during agile whether you got working software or you don't. You're going to know right away if the team is able to do what they said they're going to do within the cost objectives that we set. So anyway, we'll talk about that. It just came up from my conscious, but we'll talk about earned value management and how we get around it and not do it until they give us relaxation on it. This is sometimes the feeling, you know, I'm all the time asking question, how's it going? How's it going? How's it going? Or like, could you just leave us alone and let us do our work in a waterfall methodology? So we need to get out of that as we go through the process. Unfortunately, if you don't change your culture and if you don't change your processes, agile teams basically won't be successful. And we've been seeing this throughout the history of agile. That's from the early 2000s when agile started to arise. But there's a lot of things that are valuable to the teams developing the software. They get software teams are happier. They're able to deliver quality software. They're able to maintain their code because they don't have any forking going on. I did say forking. I'll talk about forking later in the class in the course. People are happier doing the software development. They have happier programmers develop better software. I can't over stress that. But you're like, well, why do we care? We're the government. We're going to go hire Lockheed Martin to do agile or some small business to do agile. That's their problem about hiring people and maintaining their workforce to where they're able to deliver quality software. Is it? Think about that for a second. If we think, well, we're going to do agile and them maintaining their workforce and making sure that They're able to keep experienced people on their team. How much money are they actually paying these people to develop this software that we critically need? Probably not as much as what Microsoft or Google or Apple or any of these other alphabet letter organizations are offering. So they're getting paid a fair wage. They're doing the work, but if they're not happy doing the work, they're going to go find another job. So it's to our benefit and the contractor's benefit that if we believe in Agile and we basically say we think we're going to get a quality product and we're going to get it in a timely fashion, then we need to support the Agile process as best we can from a government perspective, and don't overburden these people with a lot of meetings, a lot of BS as we go through this. Now, we're gonna talk about this process, but I wanted to show this to you now. Anybody recognize what this is? This process?
Yes.
Yeah, I mean, this is Scrum Agile. Is
Software
that what you're
acquisition.
asking? Yeah.
I don't know. What is this? What is this chart? What is this chart trying to say?
Yeah, what's the expectation of software acquisition and how the phases of iteration once you start planning, executing, and what do you expect to be in the process during time?
Yeah, it is the software acquisition pathway expanded. A lot of times when you look at the software process, you just see this top thing here, right? It says if you're going to do, and we're going to talk in detail on this, but I want to show you this thing, this spinning, adding value, adding capability, and releasing software and showing the user value, that we're actually producing value to actually get to the point that we deliver them some sort of viable capability, but we continue to add capability as they need it. So this is, there's a lot of things that we're going to talk about from an acquisition perspective, contracts, test, how do we get test involved in this? Intellectual property, cybersecurity, how do we support the product when it gets out there? How do we train? How do we do all this other stuff? So this is our strategy. This is our planning phase in the adaptive acquisition framework for software. We have to come up with some sort of cost estimate. How much do you think this thing's going to cost? Active user engagements, user agreements, we'll talk about these. But once I finish my planning phase, once I get my money in my hand, I have 1 year to get to minimum viable product. 1 year to demonstrate to the user that we actually are able to deliver a minimum viable product. If we don't achieve this, then there's a likelihood that we're going to terminate this contract and try again, maybe with a better contractor, or maybe change some processes. So that was one of the questions, is it good or bad to terminate a program at minimum viable product type of area? That is something that is in our processes, that if you're unable to get to minimum viable product in a year, then you should terminate. That brings some risk, right? If you terminate your project, is that terminate your project or terminate the contractor and let's try again? That's pretty murky. I mean, that's with you and the acquisition, the leadership, to try to figure out what went wrong and where we need to restart. So that's sort of where this goes. So we're going to chat about that in detail. Lots of words there. So that completes this whole part of the lecture. We're gonna shift to the 8.7. Is that the right one? Yeah, here it is. Okay. So so this acquisition pathway was recommended by The Defense Innovation Board, this is something that came about, and they said if we want to deliver capability at the speed of relevance, then we probably need to do something different. And when we just look around us, and as we start thinking about our systems, our warfighting systems, and all the software that is there, when you amplify and you go to the next level of autonomous systems, unmanned systems, enhanced reality, targeting systems, all this stuff is software, right? And you can just look around of all the systems that we're developing that are very software intensive. There's a sense of urgency in the DoD at the highest levels, and we need to change our processes. And this is I just bring this up. This is one of those C areas of understanding. You won't have to repeat this, but I like thinking about the 8-step change model from Collier. And basically, he's a psychologist. He basically said, if you want to make change, you probably need to go through these steps. The first one is to create a sense of urgency. And that has been a lot of the documentations I've been referring to, this sense of urgency that we got to go through this process to change. You need to build a guiding team. You need to start with having teams of experts that basically can help us through this process. Develop the vision. I've showed you the vision document that they had, that they developed. They need to communicate for buy-in. They've communicated with Congress. They've communicated with the Defense Science Board, the Defense Innovation Board. They're communicating within the DoD to try to get buy-in on this. They are empowering action. They said, let's go run some prototype programs, give them authorization to be doing some of this stuff, and create some short-term wins. Show the value of this, show the value of delivering software quick and relevant. Don't let up. You know, sometimes with changing leadership, especially political appointees, sometimes they want to focus on something else. Do not let up. You got to keep pushing on this to make a fundamental change, to make it stick. So I just bring this up that I think this is sort of, if I was to look at what has been done in the past and the steps that they've went through, this is, I'm not saying they follow this model. I'm saying it seems representative of it. So here's the one of the urgency to modernize documents, 2018 National Defense Strategy. It said these words in it, and in the latest documents say these words also. We need to prioritize the speed of delivery, continuous adaptation, and frequent modular upgrades. Software, right? Got to be able to do it. The Defense Science Board, the report that they put out, basically said the DoD must have the ability to update our systems rapidly. You don't update your systems rapidly following waterfall. And the Defense Innovation Board from 2019 basically said software's never done. So that's not my quote, but it said speed and cycle time matter. Faster is more reliable, secure, and possible. Delivering software faster is more reliable, it's more secure, and it's possible today using the technologies and cultural changes. And we need to establish a new pathway. So that's where it started in 2019. It started from this recommendation. Congress basically said, this last document said, we like everything in there, DoD, go do it. It was in the National Defense Authorization Act for them to do it. So the old way, we've talked about waterfall. The new way basically said, hey, I got a new idea. Let's go get some initial mission capability release. Let's do it in a quick fashion. Secretary of Defense at the time basically said the threat of the same old pace is real. This threat of us doing doing waterfall and thinking we have all the time in the world, this is a threat to our military. As a result, the U.S. is losing technical edge to a great power competitors like China. This is when they were talking about it. He was the CIO at the time. He said, we could be changing software every day as necessary for a factor for winning. So if we can change software and add capability at the speed of relevance, then this is a big deal for winning the next conflicts. This is the adaptive acquisition framework. You've seen this in your previous classes. We're going to be talking about this software acquisition phase. I've hyperlinked it to the DAU website. This is the repository of all the working documents, all the documents for the adaptive acquisition framework. It has software in there, very, very good source for material and information. And they even have working groups that you can get involved in if you're so inclined. Previous Joint Chiefs of Staff, basically in 2017, 2018, when all this stuff was happening, he was basically saying as the vice chairman of the Joint Chiefs of Staff, we need to insert speed into the process in the Pentagon. We need to let people in acquisition to take risk. Acquisition is risk averse, but we gotta let them do that. And we need to give them authority and hold them responsible for the stuff that they do. And our process for building software is horrible. Quotes from him. Okay. Congress was involved in a lot of this software reform. The National Defense Authorization Act, as you remember, is how Congress tells us to change in the DoD. They give us funding, but they also give us change guidance. So they allowed us to do an agile pilot in 2018. They told us to change software acquisition in 2020. They said stand up software training at DAU. They've done that since then, and stand up digital careers. That's still sort of a pending. And right now we're in a pilot for colors money to help sort of smooth out the money problem. A lot of leadership saying we need to change, Congress saying we need to change, and everybody's pushing in the right direction. Here's the directions to modernize, basically informed the DoD instruction 5000.87. Okay, so a clear signal from the leadership, from the government saying to DoD, the the workforce is important, and we need to train them and make sure they have the tools they need and the processes are lined up that we're able to deliver software. It's a national security issue. Digitalization. So here's the National Defense Authorization Act, Section 800 basically stood up and told us to create a software pathway both from an application and embedded system. So applications are like what you think. Weapon systems like Tomahawk weapon system that I worked on has embedded software in the missile system itself. We need to be able to deliver software to that to the embedded weapon systems also. Gave us a lot of maneuverability. Said skip the JSIDS process, people. Come up with a process. I think they've just come up with a process in which they're able to expedite through there. Start with an application path. It's pretty straightforward. Developing apps, we're all pretty familiar with that capability for IT systems and cloud computing. But this embedded software pathway is a little bit more complex. How do you match the weapon system, the hardware system with the software that's being developed? GAO just came out with a report a couple months ago and said, we're not doing a great job changing the way we develop software for embedded weapon systems. We need to modernize our software development practices, human-centered design, basically have active user engagement through this and commitment. We need enterprise service platforms like the cloud, Amazon Web Services, and all these other cloud. Used to be Jedi, now it's another cloud provider that you can do to develop software and host things. Rapid and iterative deliveries and government industry software teams. So they start talking about the government being part of the development team, to have interaction with the contractor, to be part of the planning, part of the process. In traditional acquisition from in the past, we came up with the plan, we put out a request for proposal, we got a contractor on board, and then we tracked their earned value and had meetings every now and then, right? Not a lot of government industry teaming. As we start talking about software, we're saying we need to do it a little bit differently. We need to change our teaming in the way that we work with them. And we need to employ tools for automated test, for automated delivery of capability. So basically, there's a lot of flexibility they gave to the acquisition community, and to prioritize speed and the ability to adapt as we go through this. As we start decomposing the pathway, they start defining some key players in all of this. And as we start looking at the integrated product team, architectures and engineers and test and evaluation, cybersecurity professionals, contracting, all these people are part of the team that need to be pulling together and making sure that we're able to deliver the software like we're supposed to be delivering. So this is not just the contractor. It is the government team, contracting team, contractors team, everybody pulling in the same direction, working together. You have, if you look at the person in the middle, the program manager is connected to the product owner. The decision authority, like your milestone decision authority type of person, usually it's at PEO level, and the sponsor who's paying for this. The user community is connected to the development team, right? This is what they're trying to convey. The user community basically is providing support to the development team to make sure that they're developing the right product. So this is how, when we say we need to be an integrated team, this is how we're sort of defining how this works. So let's go through this. I got to get my acquisition strategy right. I need to have my contracting strategy right in order to support this. I need to understand how we're going to do test and evaluation for this. I cannot overstress this operational test and evaluation thing that we do in the government, right? We hand it to the operational community and they say suitable and effective. We can no longer do that. We have to shift this organization to the left also. And DOT&E was here, the director of operational test and evaluation was here in Monterey in May last year and said, we need to do that. We are fundamentally being challenged. If we're going to develop software fast and get that capability out there, we need to be not waiting for the total package, because it's never going to be a total package. So they're trying to figure that out too. Engineering, product support, all this stuff. How do we develop an initial cost estimate? How much is this going to cost? Where am I going to find the money for this? If you look at our budgeting process, what year are we in budget right now? Here's a question. Everybody pay attention. What year of budget are we in right now?
We're in 2024, right?
Are we?
Execution
Well, we're in
versus
Trick
execution.
question.
We're on execution, so we're supposed to be 25, 26, but I think it's 26, 2 years out.
Yeah,
Right?
it depends on where you set in the budgeting process. At PPBE, we're in the year of execution of 24. When is the president's budget due to Congress for 25?
February.
Yeah, February. Guess what? When does 25 start? When does this fiscal year 25 supposedly start?
October 1st.
October 1st. Yeah. So if you want money in 2025, it's over, right? That budget is already sailed. We are working on 26, 27, right? Identifying funding is a non-trivial event. They understand this. They've actually made recommendations for Congress to provide a slush fund. I hate to use that word, but have a pot of money set aside for the unknown stuff like this that requires some sort of seed money to get started and go through. So we got a big problem on that. Yeah, I see. So where somebody said, where does the contracting officer fall in all of this? It's a different type of contracting philosophy. It is here's my vision of it. The nirvana vision of it. I need to get a contractor on board to do this work. I think maybe a multiple award contract, a MAC, that I'm able to do task order tasking. Says I have new tasking. I need a contractor to develop this particular piece of software. Okay, we understand that contracting action. If I want a level of effort type of contract, I get a contract. I basically award it to a contractor as a level of effort and say I need 25 software developers and team whatever, and they're on the payroll and they get paid and here's their profit. Okay, changing requirements is no longer a thing. I don't need the contractor to negotiate. I do not need the contracting officer to negotiate with the contractor on cost anymore, right? So if we're changing the paradigm, then we need to educate the contracting officer workforce of what it is we're actually looking for. And when I say the government team working with the contractor, with Lockheed Martin or anyone else that's doing this work, I'm talking about them working on changing requirements and not having contract negotiation on this, that I'm able to communicate directly and work with the contractor and be a team together. That's what I'm talking about. It's a fundamental shift from the way that we do business today, that only the contracting officer can give change. It's like, nope, that ain't where we're going. So anyway, answer that question. Hopefully. All right. We need to balance ourselves. We can't be, sort of willy-nilly. We're still held to accountability. So we got to balance speed with rigor. And there's some things that we need in order to go through this process. The first thing I need in order to do the software pathway is I need an acquisition decision memorandum signed by the decision authority. It's a pretty lightweight document that basically says there's a need from the user that has come down, and I have a draft capability need statement in my hand. We'll go through all this. So the user community working through the sponsor, funding wise and all this other stuff basically says I need something, and all they have to do is give me a draft capability need statement, and we'll talk about that, what it is. That's all I need to do to start the planning phase. What type of contracting strategy do I need? What type of money do I need? What type of all this other stuff? I can do that just with this lightweight document. Get the ball moving forward, okay? But I do need these documents in my hand. When I'm entering into the execution phase, we talked about the planning phase, and then there's this point of execution. I need the real capability need statement. What is it that you really want, as best as you can say? A user agreement. I need a commitment from the user community. They're going to support these sprint events, that they're going to look at the working software and they're going to give us value. So this is a big deal. I need an acquisition strategy, always needed that. I need a test strategy, needed that. I need a product support strategy, needed that, and I need a program cost estimate. So these are things that I'm working on as I go through this executing. I need to understand how I'm going to cyber secure this thing. I need to understand the intellectual property of, if it's being developed for me, I should have the intellectual property. If I'm employing a commercial software solution, then I'm probably not going to get the intellectual property. I probably shouldn't ask for it. Support plan and a card, a cost. What is the card? It's
Analysis requirements.
analysis. Yeah. Capability analysis from. But anyway, these are documents that we need. And so I'm going to have an idea of how the system architecture is going to be set up. I need to have an idea of all of the features and a backlog of capability that the user wants. And I need to update my cost estimates. I need to have metrics. Now, it says you have to have metrics. It doesn't say you have to have earned value management. So what metrics are we going to be collecting as a program manager to report out of how it's going? The Navy has, so gone, I let somebody borrow that and they didn't turn it back. The Navy basically has, if you're going to follow this pathway, the Navy has put out a set of guidance that says these are the metrics that they need. And we'll talk about those metrics during our metrics class. We need a roadmap, what it is that we're going to be actually fielding, update the strategy, and do some sort of value assessment. So details are there. You can click that link and it gives you everything you need. So let's talk about the beginning, the capability needs statement. There's a draft template here. You can click on the draft template if you want to see what it is they need. But it's a high-level document that gives us enough information to define the software solution that they need that considers the threat environment. David, go ahead.
Yeah, just a real quick question. The draft template that you just hovered over, and I saw a draft acquisition strategy previously, they link to a Mill Suite website. I'm not familiar with that. Is that some site where like you're hosting stuff, or is that where a whole bunch of public stuff is available? I'm on my personal, so I wasn't able to try logging in yet.
I actually should change these. These are DAU has all of these, so I shouldn't be going to this.
Sorry to distract. I just to get to the second link. I was trying to follow along and take a look at them.
Yeah, I'm gonna have to give you a better link.
Okay.
Yeah, it should be. There it is. It's right here. So this is wrong, but this is right.
Okay.
So if I click here on the left, of course DAU moves it. I hate shit when people move things around and break the links. I'll give you the proper links. I haven't actually looked at this since last year.
Sure. Okay. Thanks.
It's all there on the DA. It's aaf.dau.edu, I think is the website. Yeah, aaf.edu. Okay. So the draft capability needs statement really is get things going. The sponsor and the requirements manager are in agreement that this is something that we should be spending resources on, and it's coming from the operational community. And it basically is just a clear understanding of what we should be doing. This is all I sort of need to get started, right? And the acquisition decision memorandum. So active user engagement is critical to the success of this. It really only makes sense that the user has an idea of what they want. They probably are going to evolve as they start seeing things. Are like, could you do this? Could you add that? Could you put this? Could you add this feature, right? That's just sort of human nature. You don't know what you want until you start seeing the reality of it. So having active user engagement is critical into this. That way we can deliver the software that meets their needs. And having a active user agreement is really how we sort of go in. So we can understand their needs from an operational environment. I hate to tell you this. In our defense industrial base, the percentage of people that work in our defense industrial base that have any prior military experience is right around average less than 20% of the workforce. So about 80% of the workforce that is developing our weapon systems or warfighting systems were never a warfighter. So how do they know what we need in the operational environment? They don't know. They're just looking at the requirements. But if I can connect them to the actual user that is going to be using the software, what value is that, right? Why would we not be doing that? So we get a user agreement. There again, the link is probably broke. yeah, I don't know why that's like that, but there are drafts of this to help the user community say, hey, if you want acquisition to do something, this is what you need to do. So it's an agreement between the operational users and the acquisition community that they're going to be involved in helping us make informed decisions. So it's signed by the sponsor, the program management officer office, prior to entry into the execution phase. So this is something that needs to be done. An active user agreement, draft capability needs statement, and acquisition decision memorandum, and yay, verily, let's get going. The Section 809 panel, the software panel that basically gives us gave us a lot of good ideas. So basically said we should be maximizing the use of prototyping, experimentation, and delivering minimum viable products. Said this is how you do it. This is how you deliver capability at the speed of relevance. You've seen that. This goes basically through all of the planning phase and in detail what's going on. So during the planning phase, remember that we need a draft capability need statement. We need an acquisition decision memorandum to get started at 0. And then here are all the other things that are going on. We need to get our artifacts together. We need a user agreement, we need a strategy, and we need a cost estimate to get going. I'm going to try to convince you later in the quarter that if I have standing software factories out there that can do this type of work, this is almost like a task order to them. If I have like Platform One is the Air Force backbone for their software factories, that I could probably hire a government software factory to be doing some of this stuff, at least start it. In the Navy, we have the Forge that is working on the Aegis and ship self-defense systems. We have all of these software factories starting to stand up that have capability that is like, hey, if I'm a government organization, let's just say at NIWC PAC, the NAVWAR organization. If I have an organization that has a government software factory that's supported by a contractor, all I need to sort of do is give them a task and give them all the stuff they need, and I can start delivering software pretty darn quick. If I need to start from 0, it may take a little bit longer. It doesn't really define how long this phase can take, but it has to basically be fairly fast. There's no time limit on this, but to get from 0 to 1 during my planning phase, there's a lot of stuff that I need to have done. If I had a software factory that all I have to do is give them some artifacts, I could probably already have the teams in place. I wouldn't have to go solicit a contract. I wouldn't have to be able to do a lot of this stuff. So we'll talk about how do we set up software factories in order to have this done. But from a software acquisition process for the adaptive acquisition framework, it sort of assumes you're starting from 0. And I'm sort of giving you a hint. We may not be starting from 0, putting out solicitations and stuff. We may have already done a lot of that stuff. And so here's the things that are happening during this phase. We have an acquisition decision memorandum 1. We basically have some information that is coming through from a programming perspective. And then as we finish some of our planning, we'll do some cost estimates, making sure that we stay within the boundaries of this software pathway. So there's a lot of supplemental guidance on everything that's happening here and who's doing what, and that's okay, right? This is our process as during the planning phase. Cost estimates. Look, we are notoriously bad at our cost estimates in DoD acquisition. We're usually optimistic in our cost estimates. Optimistic means that we're going to do it for less money and less time than reality actually states. It is sort of how this human nature. We say, hey, you know, what do we think the cost is? We do analogy, which is very imprecise. Maybe we do some sort of parametric type of estimate, but it's like, what's it going to cost to develop this software? It's and we have to understand that it's going to be imprecise. Unfortunately, there's usually budget constraints that are sort of inflicted into our cost estimates, and so you know, trying to get it right from a software perspective, the more you do it, the better you are. But right now, we definitely don't do a really good job at doing cost estimates as far as the reality comes into play. But we'll do our best on this, and we got some reports. If it reaches a threshold limit for ACAT 2, it's a funding threshold, then you're going to have to do an independent cost estimate. That's okay. How fast can you do? You know, what are cost estimates based on? Anybody know what cost estimates are based on?
I think we learned a little bit about this, and it's partially based on similar items and the costing of those items.
It's usually based on the requirements and how hard is it going to be to fulfill those requirements. It's like the requirements aren't really defined, are they? I have a draft capability need statement from someone, some user community and a sponsor saying, hey, we need this. And we're not 100% sure exactly what it all is. And now they're saying, do a cost estimate on that. You know, it's hard enough when I know all of the requirements and the scope of the work. Now you're saying, do a cost estimate on an idea. We just need to understand that our cost estimates are going to be pretty imprecise. And we need to train our cost estimators to understand that just give it your best shot based on what you think it's going to be. So it's a pretty big deal. I'm just pointing this out. We'll talk more about it in the quarter, how we can do better. We come up with a product roadmap. We have active user engagement, understanding, and when it is we need feedback, when they need to be present. And then we're going to deliver small, frequent releases for them once we get to a certain point. And we need to deliver the minimum viable product within a year. And there's a bunch of other stuff we need to engage the test and evaluation organization, our cyber teams, and our product support teams all need to be connected. And we need to track metrics to make sure we're getting value for the money that we're spending. This is scary to normal acquisition people. Because this is not something that we do. This sort of seems, let's get started and we'll figure it out as we go. If this is your first time doing it, it is a scary process. We have some programs that have done this, and we've learned a lot, and we've given a lot more guidance as we've gone through this. Here's another visual of the strategic operations of what's going on and the things that they need, and then basically figuring it out. They come in and drafting a capability need statement, and us starting to think about it, and engaging the user and starting our process of developing software to them. What does this look like on the bottom here? Look at this. A backlog or a feature. We're going to agree with the user community for a minimum viable product. We're going to deliver 2 of these major features. And then minimum viable capability release will add this stuff. This is sprints or some sort of release type of way of delivering capability and working through the backlog of requirements. As the mission evolves, as the user adapts to the software and maybe thinking about other ways to use this, threats to the software, priorities, new technology, this is why software is never done. So what about upgrading a weapon system? We got a lot of systems out there that need to be updated, new capabilities, new software. they said, well, let's give you a view of what possibly could be. They're like, do what you think is right, but here's a view of this. So we're already past operation. It's already been delivered to operations. How do we actually update new capabilities to existing weapon systems if we can do that? It basically says, go through this user agreement and capability need statement, all this other stuff. How do we update existing software that's out there that we possibly, if we have the software to update that, and we own the intellectual property, that's another problem. But anyway, go do it. Go do the software pathway to update existing capability if we have the data rights and everything else. They just said, let's show you a vision. They said, well, what if a weapon system is in development? It's a hardware system, but it has a lot of software. Well, then this is the embedded software type of thing. How do you build software while you're building the capability? And once again, it's nonsensical because it's just an example of what it is you need to be doing, but they're coming up with ideas of how to go through this. Probably more important is metrics and to assess value. So we're going to collect metrics from the team on our performance and how we're progressing through developing the software, how fast, the velocity, how fast are we delivering the software to the user, and the quality. So we need to be collecting metrics. This is important. This is the program management part of it. The sponsor and the user community, if I'm following this pathway, shall perform a value assessment at least annually. So the customer is going to assess us in acquisition. Are you delivering value to us? That's different. That's never been done before. The customer has never had a say during the development of the system of, are you adding value or not? If you're not adding value, then you're probably going to lose your funding, and they're going to probably cause you to terminate. And so this is tied to funding resources, right? If the sponsor is not happy, who is paying the bill, then and you don't seem to be adding value, then they may just change your funding profile. This is a big build out. So notional outcomes and key results to achieve better software faster. So this is from the DoD. And so basically said, in order to demonstrate value, you need to be doing this stuff. You need to deliver capability of that value to the operational user. You need to be effective. You need to be suitable. You need to be survivable. All these things that we hold true. You need to make these decisions earlier in the time frame that is required. You need a timely release of capability to the user. You need to monitor all critical functionalities while it's out there. You need to have cyber event monitoring, the detection built into your software. Blah, 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 blah. It's like, oh my God. You know, at one time you're saying we need to go fast and we need to get there. Next time you say, but we need to do all this stuff too. And this is the process rigor part of it. We got to do everything that we've done before, but we need to do it better and faster. People throw their hands up. They're like, seems way too hard. It is hard if you're trying to do it in a waterfall methodology. It is hard if you just do agile. And that's where we're going to make this transition to DevSecOps, to where we're going to use agile developing the software, but we're going to change our processes using a different type of methodology called DevSecOps, and we'll get there. So there is light at the end of the tunnel on this, of all the stuff that we need to be doing. There is examples in the commercial industry of people being able to change and actually perform some spectacular feats that probably couldn't do it during DoD acquisition time, but changing and enabling the people to do the right thing and to follow a particular process changing our process procedures and employing technology and change our policy, right? These are all the things that we are challenged to do right now in DoD acquisition, and in order to unleash the conditions for DevSecOps is sort of where we need to go. So this is, if we look at the private sector, this is where they're going, and this is how they're able to achieve these pretty spectacularly. Is this a software program? SpaceX?
Yes.
So I'll argue the no.
I'll argue the no. What do you think is controlling all the thrusters on the return vehicle when they launch it? What do you think all those things, the ability to land on a barge at sea or on a platform on land this piece of it, right? The mission module's at the top, but this is the bottom part. What is that?
Entirely automated. An entirely automated system. So
It's
got to be
software.
evaluating every position, every condition, everything out there.
That's right. It's software. It is. I mean, Dave, you're right. There is hardware here, right? There's the components, the rocket engines, all the other stuff. But the control of these make this feasible. We've not been able to do this before, to recover and land this stuff, right? On the space shuttle, we basically jettisoned them, and they just basically fell to Earth with a parachute, and we picked them up in the water. They're able to land this stuff. All right, pretty big deal. Matthew?
Yeah, I was going to agree. I mean, some of us here probably have had a chance to actually be there at SpaceX and seeing this stuff in person, and it's pretty exciting stuff. So I think it's just a matter of, one of the things about, everyone's probably heard this, the Elon Musk's like philosophy, right? And one of the last steps is he doesn't do AI and software first sometimes when he does problems. So that's kind of the fascinating part, is that they do design themselves out of problems, but that's like the last step. It's like get it right first, and then you design yourself out, which is, I think, a part of Agile and part of what Scrum is all about, is that they kind of know that they're probably going to get it wrong at first, and they figure it out before they just jump into a software solution.
Yeah, they're doing prototypes. They're experimenting with stuff to see, is this the art of the possible, that type of stuff. We need to catch up to the private sector. I often ask, I said, is Tesla a car company, or are they a software company? Or are they an energy company? Or are they an energy company?
I'd say they're more of a data company, personally.
Yeah, I'm on, exactly.
Yeah, I'm with you. Okay. They start introducing the concept of software factory. We're going to cover all this stuff, and this is really connecting people and processes and tools into an ecosystem. We're going to talk about the Forge. This is the software factory for ages. This is DevSecOps. If you've never seen it before, it's that infinity circle. We'll chat about that. This gives us the ability to move things left and right. Notional metrics for programs are pretty important. We're going to stop here. We got to remove the regulatory bureaucracy and the bottlenecks that exist in our acquisition system. Can't accept the cumbersome approval chains, wasteful application of resources, and uncompetitive space, or overly risk-averse thinking that impedes change. So this is, we are entering into a new realm of acquisition, the speed and the threat that we have to sort of counter here. And this is a big deal. So I'm going to stop there. There's another slide deck that I didn't get to, and that is the Defense Innovation Board 10 Commandments. That is worth looking at. And I think you got to have a homework assignment on that. Really smart people helping us try to understand, what it should look like and where we need to go. And I think that's of value. So from an introductory perspective, I think that's what I want to cover.